Yeah, welcome everybody. I'm glad to have a chance to talk about the factory design utilities. As Lori said, my name is Rusty Belcher. I work with the factory design utilities really all the time. It's rare that a week goes by that I don't have a demo or an engagement with one of our customers regarding the factory utilities. So I've gotten a chance to use these for really since the tool came out. And I just love the opportunity to share the functionality of this tool with you guys today. I think I gave this presentation at Autodesk University this year, so if you were there, we actually did this demonstration. We did it as a hands-on class at Autodesk University this year, and it went over pretty good. So we're going to give it to you today. I'm going to go ahead and get started. The factory design utilities really have a simple goal to allow you to design a factory layout, visualize it ahead of time, and simulate products that could potentially move or the workflow of the facility as you design it. So you want to simulate, to the best representation of what the real world's going to be. Traditionally, this practice has always been done in AutoCAD 2D. But the factory design utilities allow us to do it now in full 3D solid model. Really, the factory design workflow accounts for just about every aspect of design when it comes to a factory layout. I'm going to start up here at the concept sketch up here at the top of the screen. A lot of us start a layout project, whether it's a factory or something else. We start on a napkin sketch or a yellow sheet of paper, and we start to lay out what the workflow or what the arrangement would look like. That moves into the digital engineering phase, the initial modeling or the initial drawing of the layout. Potentially that could unveil some simulation possibilities, time studies, empirical testing, things of that nature. But eventually it ends up on a 2D drawing. Where we can go and start to fabricate our design. A lot of times it stops here at the 2D drawing, but with the factory design utilities, we can carry on to a full 3D model. And we can actually almost take a virtual reality tour of the facility before we commission anything into construction or production. So really, all aspects of the factory layout process are covered with the factory design utilities and the product and manufacturing collection available from Autodesk. It really does address all of the digital prototyping needs for factory layout. So we're going to be taking a look at what's inside the product design collection, how it's used for the factory layout process. I'm going to focus a little bit on the factory utilities in this presentation. I'll try to show you some of the basic stuff it does, and I will try to expand upon that and take a look at the asset-based workflow and how it can be utilized in designs other than factories. I get this question a lot, what is in the product design collection? Autodesk offers these tools in collections now. There's really three main ones. There's the manufacturing collection, the product design collection, the architectural, engineering, and construction collection, and the media and entertainment collection. And you purchase what, the realm of discipline or the discipline as far as design that you're concerned with. The product design collection includes some main tools, AutoCAD, of course, and Inventor. Those are, in my mind, the two main tools that are part of the collection. But there are also other tools available, and I wanted to just take a moment and share with you what tools are actually available in the collection. So I have most of them up on the screen. I think this is basically it, starting with Inventor and AutoCAD. Inventor is the core 3D modeling tool at the heart of the product design collection. AutoCAD is certainly there. All flavors of the AutoCAD are available. AutoCAD Architecture, as well as AutoCAD Mechanical, Electrical. Even if you wanted to get your AutoCAD on your mobile device and carry that out in the field, all of that is included. Of course, the new Fusion 360 workflows that are becoming available, that's included, as well as a basic installation of Vault. On top of that, you have Navisworks. We're going to talk a little bit about Navisworks today so that you can visualize massive layouts, layouts that are bigger than your CAD tool can support. Recap 360 is your interface with reality capture. It allows you to take laser scan point clouds, bring them into your AutoCAD or Inventor environments, even Navisworks, and see your design, digital design, in context of reality, and you can compare the two. And of course, built into all of this is the factory design utilities. The factory design utilities actually add functionality to Inventor, AutoCAD, and Navisworks. I have that up on the screen. The factory design utilities integrate with AutoCAD, Inventor, and Navisworks. It is important to note that you also have 3D Studio Max for high-end visualization. I've already mentioned AutoCAD or Autodesk Recap for reality capture, and Process Analysis 360. That's the tool I mentioned early on that we use instead of a napkin sketch when we lay out our initial design. You know, with the factory layout process, there's a lot of challenges that are inherently involved. Forever, the factory layouts or plant layouts have all been done in 2D from a top-down point of view. And that's nice, it has worked for years, but there are some inherent problems with the 2D approach. A lot of times you'll miss interferences that would be readily available to you if you looked at this in 3D. You could actually see it easier and see where the interferences are. Sometimes your line interferes with the building, which just doesn't really show up very well in a simple 2D schematic drawing. It's often hard to collaborate with other people on your team because only one person can get into the file at any given time. That's not very efficient design or collaborative process, especially when it comes to change. A lot of times a change will just cripple a project design because it takes so long to adjust the change in so many different views in conventional AutoCAD. It's hard to get lean in your manufacturing. I know a lot of people that have to do layouts as part of the bid proposal, which is free work. And they spend a lot of time and they invest a lot of time and hours doing the initial layout for free, hoping that they'll get a contract. And you really just can't sustain a business giving that much time and effort away for free without a good return. So the factory design utilities really do enhance the overall process. They answer all of those typical issues with the factory design workflow. It brings together the power of AutoCAD and the power of Inventor to address the factory layout workflow or the factory layout solution. The solution is bidirectional, so you can work in AutoCAD when it makes sense, and you can work in Inventor when it makes sense, and the two talk and update automatically. Oftentimes in our world today, we're just used to seeing things in 3D. It's a 3D world. Everything we look at, young people coming out of college right now, they are what we call digital natives. They've been seeing things in 3D their entire engineering career, so of course they want to see it when they come into the plant layout or the factory layout arena. And I think it's quite simple and effective to use. You're going to see here in a minute that we're not really adding a lot to the process. We're just including 3D in the conventional workflow. The overall idea is that we win more business. You spend less time doing the free work. You get more business coming in because you can adapt to change faster. You can visualize the concept better than your competition. And you can address change. If a change happens, you're going to be surprised at how easy you can handle that with the factory utilities. And we're not getting rid of AutoCAD. We're simply enhancing its capabilities with the other members of the product and manufacturing collection. So I want to give you a quick demonstration of the core factory design functionality. I want to start off with that. If you've ever seen me give a factory demonstration, this is going to be a very abbreviated version of that. There could be people on the call today that have never seen the factory utilities used in context of a factory. So I want to start there. I am going to jump in to a tool called Process Analysis 360. This is a tool you get with the Product Design Manufacturing Collection. I mentioned before, it's much like the very first time you sit down to do an analysis of a layout. You don't typically want to start in a CAD tool. A lot of times we make a mistake when we dive into AutoCAD or Inventor too quickly. We need to lay out the design first. So I have one that I've already done for time's sake. I've already built a simple schematic. I've got a couple of bins here that contain some raw material. These bins basically are almost infinite in nature. They'll never run out of material. They feed an hydraulic press where these two parts A and B, are stamped together and merged together with the press. Then the parts move on to a buffer or rack where they sit and wait until one of the other presses become available, and then eventually they'll be packaged and shipped up to an end quantity. And my target quantity here is 50 parts. So the process analysis tool lets me lay this out very quickly and easily. It's a drag and drop approach to bring in parts and buffers, products, source objects, or processors, and lay out my design. And then I can also associate them with an existing 3D model if I have it. You don't have to have it, but if you do, it's nice. The overall goal here is that I can simulate the process, and I can see where I have possible bottlenecks. So if I run this right now, you'll see that press A, the current production rate's actually pretty high. We're really hammering press A. But notice my buffer very, very slowly filling up, but that's okay. And if I speed up time here, we'll get to a product count of 50 in just under 2 hours. Now this is my final result. Let me show you what I started with. In the initial layout here, we didn't have these two extra these two extra presses. So if I rerun the simulation, I'll do it a little slower at first. You can actually visualize the bottleneck. You can see right away that the press is actually filling up the buffer way too fast. You know, I've only got, what, 4 or 5 parts done, and my buffer is already at 50% capacity. This is what a bottleneck would look like with our process analysis tool. Now again, I'll speed this up. Eventually we'll get to a sustainable rate, and we end up with a work run of about 5 hours and 16 minutes. Well, if I needed to justify going out and installing 2 new presses, this is the way I do it. I would simply lay out the workflow, I would copy press B, and I would paste it in, just a simple paste. I'll do another one. And to modify the workflow, we'll just drag and drop the lines from the buffer to the press, and then from the presses to our final product, or our final product count. I can reset it and run it again just so you can see it run again. And we get to 50, and again, a little under 2 hours. So I can visualize the benefit of adding extra machines to my workflow. I can prove that out. We can generate reports. There's a number of things I can do. One of the things that is interesting, you can actually export this to Inventor, and because you have models associated with each step, Inventor and the factory utilities will automatically model this for you. Now, that's when you bring in the building and you start to lay out or arrange everything in context of your actual building or your actual layout. But this work has to be done before the traditional CAD work is done. The process analysis tool allows us to do that extremely easily. I've also had a number of people want to use this tool to map out their current process. They'd like to go machine to machine and record empirically what those machines are doing so that they can get down into an understandable diagram what their current workflow is. Once they do that, then they can start making changes and seeing where it's possible for improvement in the overall workflow or the overall design process. So process analysis is kind of the kickoff point with the factory utilities. It is part of the product design and manufacturing collection. I am going to minimize that. I can have it open if you guys want to talk about that afterwards as far as a question goes. But I want to jump into Inventor. I want to take another look at the overall factory utility process. Quite often I find myself with the factory utilities, I work in Inventor a lot of the time. There are workflows that are AutoCAD-centric, but I'm going to share with you the Inventor-centric workflow with the factory utilities. So I have them installed, and basically what this does is it adds a factory tab to AutoCAD, Inventor, and Navisworks. And depending on the tool you're using, you have a set of tools for the layout, the factory layout process. So I'm going to start a new layout. On the factory tab, I'm going to start a simple new layout. And if you guys bear with me, I'll go back up here to my main assets. So you'll notice if you're an Inventor user already, you're going to notice something new, this floor object. That's one of the big differences between a factory assembly and a traditional Inventor assembly. It's the presence of the floor. All of our assets are going to land on the floor in an upright orientation. So the floor is an object. There is really no physical object there. It is a graphic. If you want to think of it as a dedicated work plane that represents the floor, that's kind of the idea. You'll notice the traditional red and green axis, the x-axis and the y. And if you're a traditional Inventor user, look which way up is. In this assembly, Z is automatically set to up, which is different than traditional Inventor, but it falls into the traditional practice of existing factory layouts that have been done that way for years inside of AutoCAD. The first thing I want to do in my project is to add my existing AutoCAD data as an underlay. Surely at some point in your process, somebody has drawn the building, somebody's done a simple AutoCAD layout of the facility, and maybe even the initial design of the layout. Well, I can start my project by utilizing traditional AutoCAD data. I'm going to go in and start a file based on a simple little factory layout that I have. And you'll see my AutoCAD lines immediately pop onto the floor full scale. Very nice. You'll see that the AutoCAD drawing appears in my browser as a design node. I can right-click on that and do a number of things. Layer visibility for one. I can actually go in and turn off and on certain layers in the AutoCAD file. In this case, I'm going to turn off all the secondary conveyors. I just want to focus on the one in the corner for this part of the presentation. This is a live link, so somebody could be working on this file while I am doing the initial layout process, and if the AutoCAD file changes, I'll be prompted to update the reference. Now, again, if you've ever seen me do a factory demonstration, I typically do this layout quite a bit. But here is my AutoCAD footprint. Here is the asset browser. This is another major component of the factory utilities. This gives you access to thousands of models that Autodesk has already provided you. Categories, architectural categories, building utilities, automotive categories, any number of categories you can imagine. They are all available to you basically out of the box. Material handling equipment, process equipment, placeholders, and even point clouds, reality capture. Even things as far as retail space, safety equipment, some of the things that are here I'm going to mention a little bit later about using the factory utilities in a way that's not a factory or in a design that's not a factory. But I'm going to use the basic conveyors. Anything I show you with a conveyor would work with any asset that you place into any factory layout. Now I'm going to grab some belt conveyors, and I'm going to start off with a simple straight belt. So I can bring this in, and you'll notice it pops in on my cursor, simple drag and drop, and I can snap to my AutoCAD data. zoom back in here. When I drop off the part, the reposition tool allows me to easily move it around or spin it to the correct orientation. I'm immediately given the opportunity to do a second instance, and you'll notice that as the two instances come together, they're automatically snapped together and they align based on that little green dot that's at each end of the asset. That green dot's called a connector. Well, these assets are quite intelligent. Let me grab just another conveyor over here and drop it off to the side. I'll just spin it around. The assets have properties. When I select an asset, the factory properties light up. These are all the parameters that were used to create the asset, things like length, width, and height, the number of legs or the number of horizontal rungs or the motor location on the asset. If you can model an inventor and you can include, if you know how to include parameters already in your inventor designs, you are 75% there as far as being a factory design expert. All I have to teach you is how to put the connectors on and how to put a landing surface, and your asset's done. So if you're a current inventor user and you're not utilizing this, don't be intimidated with it. It's quite simple to create your own assets. But when I select the asset, I very much it's like an iLogic table. The factory properties are available, and I can immediately change things. How about I want the length of 288 inches. If I enter, you'll notice that the length of the conveyor changes. I get extra legs on the conveyor based on whatever standard I'm using. So I'm going to delete that. I want to add some more stuff here. I'm going to add a curve. Let's do a horizontal curve. Let's snap that together. Even a transition. I have an incline belt here. And you notice how easily those things snap together. Now, the same horizontal curve here, I'm just going to drag that in again. This time I'm going to dock it or snap it or connect it up here at the top. You'll notice when I do that, the legs automatically lengthen to match the floor, to meet the floor. The same thing with the straight conveyor. If I hook it up here, the legs will lengthen. Parametrically, it's built into the design that the legs always land on the floor. And over here, I can drop the same asset, and it comes in different each time, or it can come in different. Now, I don't want to spend a lot of time laying all of this out, so if you bear with me, I'm just going to drop in a few extra pieces here. You can see how quickly you can actually develop an assembly with the factory utilities. I'm going to change my category of conveyors. I want to grab some roller conveyors. You can actually see how many conveyor types are available. I'm going to grab a couple of straight conveyors, and we'll just dock those or connect those right here. All right, so we've got the basics of our design done. Let me go ahead and run a save. I'm just going to save this as a sample assembly. So one of the other things that the factory utilities bring is the easy interoperability with other CAD systems. As an example, I want to bring in a model from another CAD system and that somebody else has created for the big piece of machinery that's at the end of this conveyor line. The factory layout utilities has a tool called Insert Model. Now you saw how the assets work. You saw that they landed upright on the floor. You saw that I could position them exactly where I want. Well, this command gives that functionality to any model that I insert. Let me start the command, and let's just take a moment and look at all the different file types available. You want to work with SolidWorks or Solid Edge? Not a problem. Step, IGES, ACES, all of those are here, Pro-E, even Revit and Rhino. You never know in this game what other people are using, what your collaborators, what's their CAD tool. We're all using something different. CATIA, JT, NX, even OBJ now for meshes. Autodesk is starting to bring meshes into play here. All of these things are available to come into my design. So I'm simply going to grab a part. I already have it set up. It's called a blower. It's a large piece of equipment. It was initially created in AutoCAD ages ago, but I can bring it in. And you'll notice that regardless of the operating system, the model lands on the floor. The factory utilities encases it in a bounding box, and the bounding box is what lands on the floor, no matter what. If you're working with a CAD tool that has a different up direction, Inventor is famous for Y being up. Well, that's not a problem. You can orient the design with either X up, Y up, or Z up. Once you commit to landing it on the floor, you can move the reposition tool to a known point. Then I can pick it up from there and snap it to its footprint. So very quickly, I can take a model that was generated in another CAD system and put it right on top of its footprint inside of Inventor. So generating a layout with the factory utilities is, I think, incredibly fast and efficient. I've worked with Inventor for coming up on 18 years. And I've taught Inventor classes. I teach Inventor classes basically once a month to beginners. And a user who's beginning with Inventor, when I give them an assembly exercise, I can safely assume that they can model 4 or 5 parts in an hour and put them together. And that's, you'd be surprised, even veteran users might get to maybe 10 parts an hour and put an assembly together. With the factory utilities, you can create an assembly with 150 parts in 15 or 20 minutes because it's simply drag and drop and snap to fit, and then move on to the next line or the next problem in your overall layout. The factory design assemblies often have hundreds or even thousands of components built into them. So I do want to run save. I want to jump into and do a drawing. I think any demonstration of this, we've got to include drawings. So let's go ahead and look at just a standard Inventor DWG. Let me select my base view. I'll generate, I don't want that shaded. I'll generate my top view and my isometric view. So if you're an Inventor user, you're used to being able to generate drawing views that quickly, and it's amazing. But with the factory utilities, a lot of things that we take for granted in Inventor, our traditional AutoCAD brothers haven't had access to. So I show an AutoCAD user this, and they're floored. If I go to the Annotate menu and I grab a simple parts list and drop this off, this functionality is not available in basic AutoCAD, but it is inside of Inventor. Counts up all the parts for me. It names them automatically. I can even go and start dropping in the balloon identification. Annotating inside of Inventor has always been, I think, very easy to do. Now, I'm not going to do all of this. Just want to do a little bit. You might notice that the tall straight conveyor over here is item 1, and the short conveyor over here is also item 1. Same thing with the curved conveyor, item 2, and the tall one is item 2. Well, that's, again, the ability of Inventor to roll up item numbers that have the same name. If you don't want that to happen, it's in the assembly. You can go to the bill of materials and basically say, do not roll up. Don't roll up the parts based on the same file name or the same part number. So when I go back into Inventor, or I'm sorry, back into my drawing, now I have unique numbers for the tall assets and the short assets. If you're a traditional, or I'm sorry, if you're an experienced factory design user and you're sitting through this presentation, let me show you one of the newer features that I'm really excited about. I really do love this. I'm going to select this view, and over in the browser, you'll notice the view highlights. I can expand that. There's the assembly. There is the DWG underlay. Well, I can right-click on that now and include it in my design. So here is my Inventor design and the AutoCAD design on the sheet of paper ready to go. Now, thank goodness, you know, it's such a large view. But thank goodness on the Place View tab, there's a crop tool. We can come in and crop out the view, basically showing just what we want. And let me do that again, just undo that. Let me do it right. There you go. So here's my AutoCAD drawing underlaid or overlaid, a lot of people like to say overlaid, on top of my inventor design. And you can fully annotate this. For installation purposes, if I need to come in and add a dimension, let's say I want a dimension from the column support grid to the center line of my conveyors, I can easily do that for installation drawings. I can go right back over here and grab another grid line to the center line, and I can include that in my overall design. This way, when the installers come in, there's really no question as to where these pieces should actually be and how they should line up with reference to the building. Even if I wanted to dimension off of a wall to the center line of a conveyor, we can do that as well. There you go. And of course, again, this is a live drawing. If the model ever changes, you'll see those changes automatically appear in the drawing design. Let's take a look at change. This I mentioned earlier in the PowerPoint. How you deal with change oftentimes affects how productive you are or how profitable you are in this particular design discipline. So let's say, as an example, I need to integrate a new piece of machinery into the line. I have a quality inspection station that I need to account for, and I'm thinking we can put it right here in place of this conveyor. Now, again, think about changing an AutoCAD drawing in terms of this, having to go in and erase all the lines, delete the block, or rearrange the block. So many people I know would basically copy the design. They don't want to harm the original. They'll make a copy of it and go change the copy. Then you have multiple copies of the same design, and it gets to be a nightmare to try to remember which one is the current active version or which one is represented in the current drawing. Well, with the factory utilities, I can unsnap assets as easily as I can snap them together. And if I move an asset, the assets attached to it will also move with it. This allows me to go out and to get my own assets. One of the big benefits of the factory utilities is this right here, the user asset category. This is where you get to take your own models and make assets of them. I've created assets for the past 8 years. I have tons of them in here. And we'll talk about some of these a little bit later in our presentation. I am going to go into my machines here. Here's my quality inspection station. I'm going to bring this in, and you'll notice I set it up so it snaps just like the conveyors snap. I can then bring in the rest of our design, put that there. Now, I'm going to delete this one, and I can drop it in anytime I want later on. But if I save my assembly and then go look at my drawing, you'll notice that the drawing automatically updates with the new information. The bill of material updates. So I can easily come in and include that change in my current documentation, and I'm done. I'm on to moving into the next phase of the project. Now, also here, I see the difference between the original AutoCAD drawing and the current one. I might notice that, hey, that column, this is not going to work. The column is in the way. Well, okay, it's easy to move it back. I can simply jump back into the assembly. We'll delete the inspection station. Good old copy paste. Where would we be without that? Control C, Control V. We'll bring this up and snap it there and put it right back where it was. Go back to my drawing, and it's updated correctly. So change happens, and how you deal with it or how efficiently you deal with it oftentimes, impacts your bottom line as to how profitable your project is. So let me save, at least let me save the assembly in case we need to talk about that a little bit later. So that is just a very brief look at the default functionality of the factory utilities. This is what I've shown you, I believe, is the way it was set up to work from Autodesk. If you talk to them, they're basically going to give you the same general workflow that I just shared with you. Now, I want to move on to the next aspect of this presentation you guys are sitting through today, and that is, what else can we do with the factory design utilities? Why would a typical Inventor user even bother with going out and adding those to their current installation? Let me start off by saying, if you're up to date, if you have the last 2 releases of the Product Design Collection, 2018, 2019, you have the Product Design Utilities. You don't have to go add or pay anything else. You have them. Chances are you just might not have installed them, or you might not have known that they're available to you. But I have customers all the time that just love the asset-based workflow. They love that idea of dragging components from their browser into the design and snapping them together. I'll ask a question. How many of you guys are AutoCAD users? And I can't see you, but I would imagine quite a few of you are. If you're in this presentation, this is a good chance almost all of us are AutoCAD users. Imagine doing this process in AutoCAD without the block functionality. All right? I would hate to use AutoCAD if I had to draw every line, every circle, every fillet, one at a time. Even if I could copy paste, I still wouldn't like it. Blocks are essential to the factory layout process. Well, where are blocks inside of Inventor? What is the Inventor equivalent of a block? You're looking at it right here. The factory utilities, the asset-based workflow, really do equal those 3D blocks we've always wanted inside of Inventor. And the way that and how easy they are to use, it just reveals, or it makes so many different workflows possible and easy to develop with the Inventor application. I'm going to give you just a very brief kind of a year in my life. Some of the customers I've worked with in the past couple of years. And I want you to notice in this part of the presentation how they're really not factory users. They don't own a factory. They're not laying out a factory floor, but they're utilizing the factory utilities in Inventor. One of the projects I did, I worked with a company that makes wooden furniture for children. If your kids are in kindergarten or preschool, they have nice little seats for the kids and lower tables and activity areas that are sized for the children. This company makes those components. They are given a classroom layout by schools across the country, and they fill in their classroom with their products. They actually show the schools a potential layout of their products in the school space, and they get bids and they produce furniture for those schools. Utilizing the factory utilities is perfect for that. I worked with command and control centers where we've actually laid out an entire command and control facility, server rooms, and the really complex desks that people are using to monitor security networks or the internet, cybersecurity networks. All of those things have custom rooms with big wall monitors and people who really can't get up from their desk without being relieved. So we've laid out a couple of those with the factory utilities. Maybe you're the person that's building the custom furniture for this layout, and you need to show the customer what it would look like having your furniture in their command and control center. One of the first demonstrations I ever did with the factory utilities was for a supermarket, but we have worked very closely with major retailers around the world to take a retail space. You know, if you go buy clothes from a typical a chain of stores, if you go from different stores to different store, or the same chain but in different stores, you'll see that they have the same nested tables, the same default coat racks, or the same default clothing shelves. The thing that changes all around the world is the space they have to fill that material out, or they have to fill in with those assets. So we work with major retailers to prove the idea that the factory design utilities can be used to lay out any retail space with a common set of assets. I really do like event planning. I've had in my mind a couple of projects I've watched through the years. And event planning, when you change a venue from its traditional source to its new source, there's a lot of things that go on. A lot of little things have to happen to turn a race car track into a football stadium, or the deck of an aircraft carrier to a basketball court. These are things that have actually happened, and watching those, I think the factory utilities are a great tool to do these concept designs. What would the stadium look like, or what would the racetrack look like if we were to convert it to a football arena? This is the Bristol Motor Speedway, and if you're familiar with that venue, you might know that they held a couple of college football games there last year. When they were initially doing the visualization to show people what it would look like, they paid some poor guy to go out and spray paint a football field on their infield. They actually did that in spray paint, full scale, to show somebody what it would look like. And the whole time I'm just pulling my hair out. Man, even AutoCAD could have done it more efficiently than that, but the factory utilities do it very, very well. And the NCAA now plays a lot of their games. The first few games of the year, they'll play on board a naval ship. The first time they did this was on board an aircraft carrier, and I took that project and reproduced it with the factory utilities. It worked very well. We've worked a lot very closely with people who do exhibit spaces for the shows like Comic-Con or CES. They have these manufacturable panels that snap together to create any exhibit space you'd like. So not only can we create and manufacture these very elaborate exhibit spaces, but we can also lay out the entire show floor and show all of them together, and so you can manage the venue as well as the floor and all the sub-spaces in there inside of one off-the-shelf tool. I work a lot with shipbuilders, and shipbuilders have, in my nature in working with them, I've gotten a chance to spread the message of this asset-based workflow to ship compartment layout. I've had a chance to work with the biggest shipyards in the country as far as dealing with this. I was even invited to go to Portsmouth, New Hampshire to present this to the submarine builders. And in both cases, I had to actually model a submarine and model a ship deck, and I did that with the factory assets, just like you saw those conveyors earlier. I've worked with Substation Layout. There's actually a tool that you can purchase now. It's called the Substation Design Suite, and guess what it's built on? They bring in these substation assets, they drop them in place, and they use a lot of the factory functionality to support this customized version of Inventor. In the past year and a half, really 2 years, I've gotten a chance to work with our reality capture team and to bring up this idea that I want to use assets from reality. I want to go out and scan equipment. I want to scan the facility, and then I want to put them together inside of a digital environment so that I can generate what the potential new layout would be using my existing machines. In this particular workflow, there is no modeling done at all. So what are the things that really do affect or draw other people to the factory utilities? What are the main bullet points why people choose to work this way? Well, I think we've talked about it, the floor. A lot of us have a design that's laid out based on a ground plane. A lot of us like to use that DWG underlay workflow where you're actually modeling in context of the existing full-scale floor plan. A lot of us like that idea of LegoCAD, those assets that snap together, and how easy it is to create your own custom assets, including parameters. The ability to use large layouts, extremely large layouts, to get the overall aspect, to see what the entire design looks like. I can do my factory layout, and I can also do the one next door, and the one next door to that, and I can show it all together at the same time. The workflow is easy to understand, it's easy to learn, the tool is easy to use, so easy that even your tradesmen can start to utilize that. So real quickly, I want to do a simple design. I just want to take a few minutes and do a simple design that's not a factory layout. So on the factory tab, I'm going to start another new layout. And this time, I'm going to do my DWG underlay based on a ship deck. So I'm going to come in and grab the ship deck here. We'll open that up. There's my ship deck full scale. And I can come in and create, I'm going to create a bulkhead for you on board a ship. So I can grab my measure tools. I can measure that line right there. It comes out, what, 541.97. Let's call that 542. So if I can remember that, I can go into my own assets. I can develop my own set of assets to do what I want it to do. I can go to my ship design category and go to structural. Let me grab a bulkhead from the middle out, just a simple little bulkhead. Now I'm going to snap it right there. I'm going to zoom in on it. Now when I select this asset, I took a lot of time building this one. This one took me about a day to put together. I used multi-body processes, I used parameters and things like that to make it work the way I want. But when I select it, I can plug in the length. What did I say? 542, enter. Part gets longer. The bulkhead actually interfaces with the shell, so at the end there's a slope. Well, I can turn that on. I can come in and turn on the slopes at the end. Just a simple on-off feature, we can include that. So now the bulkhead would intersect the shell at a given angle. I can also turn on my hatches. Let me come up and grab a couple of hatches. I'll turn those on. Could have a hatch inside this bulkhead. Let's update that. Let's see the two hatches. And I can also determine what stiffener those hatches land on. The stiffener at the center line is 0, and then you count port or starboard, which one you want. So let's say, let's go to 4 one way, go to the 4th stiffener. The other one will go to the 5th stiffener. We'll click Update. So there is my structural model of a bulkhead for a ship design. I'll ground that out. And again, time getting away from me, I have to kind of abbreviate this, but I think you can see how easy it would be to develop an entire ship deck if I had assets like this one to lay out all the bulkheads and all the machinery, the HVAC, the ductwork, and everything else. Real quickly, I do want to talk about HVAC. So it's kind of representative of what you can do with the factory assets. Let me bring in a piece of ductwork real quick. We'll see what I can do with the time I have left. This particular duct, I want it to be 84 inches long. I want it to be 15 inches wide. Let me update that, and we'll have to reset it again on the floor. So there you go. It's set on the floor. I want to ground it so it doesn't move. So look how hard it is for me to do an HVAC layout. I can actually snap these components together. You'll notice that they actually resize themselves. So if I pause for a minute, you'll notice it's too small at first, but it resizes automatically. Let me grab a T-junction. We'll drop that in place. Let me grab a couple of flat curves. I'll finish up with just a simple straight section here. We'll do a transition. This is a sheet metal part, so you can include your sheet metal parts, get your flat patterns from those very easily. Also, let me just end up with a round duct right there. Now, you saw how the parts resized based upon how I snapped them together. Let's say, as an example, I select one of the components, this one, this horizontal one. Let me change it to 21. I'm going to go with 18. I'll go with 18. Let me update it. So you'll see this one update, and in a second, you'll see all of them update at the same time, except for the round bar because it's on the opposite side of the transition. The round duct doesn't update. But that's how versatile these assets can be. That's how functional you can develop a process to lay out piping, to lay out HVAC, to lay out electrical cables through a building or a ship like this. To finish off, I definitely want to show you Navisworks just for a moment and let you see some of the potential benefits of using the factory design utilities. Navisworks is the other component in the product design manufacturing collection. Its overall goal allows you to create massive assemblies, assemblies that are far beyond what Inventor could do by itself, what AutoCAD could do by itself. I'm going to start by looking at the ship real quick. It's one of my models. I'm really proud of this one. I was given a few years ago, I was given the challenge to take a week with the factory design utilities and see how far I could push a ship design. So with Inventor, it doesn't matter really what tool you're using, Inventor, AutoCAD, STEP, IGES, ACES, Siemens NX, even 3D Studio, SolidWorks, CATIA, even Google SketchUp or DWF Design Review. All of those models are honored inside of Navisworks. There are other ones as well. But when I talk about large assemblies, this is one of the largest ones I've ever built myself. You saw that drawing, I simply laid out all the structure. I ran as much HVAC and electrical cables as I could, piping. I added machinery from a CAD source that I have access to. So I added diesel engines in the back, and I added even point clouds and reality capture. I built that into the workflow as well. And I was able to show, or I am able to show all of this with the Navisworks application. I have full access to all the file properties. I could literally step inside and walk around, almost like virtual reality, so that if I'm trying to show somebody what it would be like to go from the berth over to the shower stall, we can actually do that. I get lost here, just like you get lost on a real ship. But I can actually show somebody what that would be like. Kind of like desktop VR, it's what I like to call it. Well, I showed you the factory earlier. Let me open up the factory. This is a version of what we teach in the class. If you come to the factory design training class, we do this particular layout. So let me jump down on the floor again. All the file types you see here are available, even more. This one I mentioned Revit. The building can be done in Revit, so you can get that building from a number of different places. But I can walk around. You can interact with the environment. So if I wanted to walk up steps, I could easily hop up here and look around. It's a very lightweight model. You can actually email these quite often to your collaborators. But here is the layout we did earlier today in the presentation. It's a simple little layout that we put together, and we can come here now and we can take a look at it inside of that Navisworks environment. But not only this, I can take a look at the architectural model, I can take a look at the civil model, I can take a look at some of the transportation stuff that's been added downstream from this. You can look at the entire project all together at the same time. So again, in our abbreviated time here today, I hope I've given you a good glimpse of the default workflow with the factory utilities, what the advantages are, and the idea that it can be used in other designs other than factory layouts. If you are interested in a further demonstration, one that I'm not constrained to an hour, let us know. IMAGINiT has account representatives all across the country who are really waiting to talk to you about the workflows available in the factory utilities and how they can be made to suit your particular needs. So I'd encourage you to make contact with your design or your account representative and possibly schedule a factory design demonstration for yourself. So at this point, we'll open it up and to any questions that you might have, Lori.